Hi, my name is Landin Noland. I'm a senior at UC Davis studying ecological management and restoration. This research was made possible by my mentor, Dr. Valerie Ebner, by Michelle Halber of Pepperwood Preserve, and by the UC Davis Honors Program. So let's jump into it. Can California's chaparral persist with more frequent fires? Chaparral is an iconic California vegetation community, which many of you may be familiar with. It is also, like many ecosystems in California, fire adapted and has a historic fire return interval of between 30 and 100 years. Now, the canopy forming species are woody shrub species, and they have two major methods of post fire recovery. Some of them are obligate germinators, such as the ceanothus, which means they rely solely on a dormant seed bank to germinate after a fire. Others are facultative resprouters, which also germinate after a fire, but can resprout from a surviving underground root system. Now, fire in California is under flux. Over the last decade or two, we've seen a sharp uptick in both fire size and intensity, as well as fire frequency in the landscape. Some areas are being burned multiple times in a decade, whereas they historically would only burn once every 40 to 100 years. And this leads to a couple of key concerns for chaparral, which center around those recovery mechanisms. First, how much fire will overwhelm those recovery mechanisms? For example, those that resprout, how many times can they resprout before their energy reserves are depleted and they can no longer do so? Alternately, for the germinating species, how many times can fire sweep through the area before the seed bank is totally depleted and those species are essentially extirpated from the system? And if those recovery mechanisms differ, then how will that affect shrub diversity within the chaparral stands? And ultimately, we're getting at how resilient is this system to an increase in fire frequency? This leads us to the Pepperwood Preserve. This is a 3,200 acre preserve in Sonoma County with a diverse array of ecosystems and soil types, including several independent stands of North Coast chaparral. Now, Pepperwood had not seen fire since the 1964 Hanley fire that swept through most of the preserve until 2017, when the Tubbs fire came through a lot of Sonoma County and burned 95% of the preserve. Subsequently, Nomad Ecology did a holistic plant survey in the chaparral stands, where they looked at chaparral as well as herbaceous and geophytic species across soil types. This became foundational to my study, which is looking at an uncharacteristically short fire return interval in the system, because in 2019, the Kincaid fire came through and reburned about 60% of the preserve. Now, in doing so, it also reburned about half of those nomad plots. This provided me a really interesting opportunity to go in and reestablish some of these plots, as well as add some of my own. So I reestablished plots 2 and 3 and plots 4 through 7 of the Nomad Ecology report. I also added 5 more replicates down by plots 4 through 7 because this area is all of the same soil type, which eliminates some inherent variation due to soil, as well as the fact that this area is close to the fire line. Therefore, I had easy access to both once and twice burned plots. So I tried to echo Nomad Ecology by reoccupying some of their plots as well as establishing some of my own, and then following their methods by running a 50-meter transect up the hill. And I then established 8 1-by-1 meter quadrats along each transect. This left me with 88 quadrats, roughly half of which were burned once and half of which were burned twice. Now, my metrics centered around 2 major questions. How are the shrubs recovering? And is there potential for grassland conversion? So I did a shrub species count, differentiating by seedlings and resprouts, as well as a species percent cover and herbaceous percent cover. This is what a typical transect in a once burned plot looked like. You can see the shrubs are pretty high, waist to chest high, as well as dense, and there's very little herbaceous cover between them. This is compared to a twice burned plot where you can see the skeletons of the shrubs with a little bit of recovery, as well as a lot of herbaceous cover in between those shrubs. So has the shortened fire return interval affected shrub and herbaceous cover? Maybe. So on the left-hand side, we see the percent cover of woody species, and there is a large difference between the once and twice burned. However, this is to be expected, right? This is essentially reflecting the number of years since the burn, which is the number of years of recovery of the shrub. So the once burned plots have had 4 years of recovery. The twice burned plots have only had 1 growing season, and this is their second. So that's kind of to be expected. Now the herbaceous cover also increased in the twice burned plots, but it's sort of unclear if that's what the once burned plots did look like at one point, and now the shrubs have outcompeted the herbaceous species, or if this is novel to this system. So we can't really say a lot about the potential for grassland conversion by this data. However, the story continues when we look at shrub diversity and composition. So has the shortened fire return interval affected shrub diversity? In short, yes, it has significantly. So this is a Simpson's index of diversity, where 1 is infinite diversity and 0 is no diversity. These systems, these chaparral stands, typically have sort of low shrub diversity because they are often dominated by ceanothus and chamise. There are 7 to 9 species that we did see. However, they were typically dominated by the 2. However, in the twice burned plots, we can see that the diversity plummeted by more than half, actually. And this is really interesting, and so it requires us to look deeper. And to do so, we really need to look at those different recovery mechanisms. As a reminder, ceanothus is dependent on its seed bank, whereas chamise can resprout. So in short, the seedlings were very hurt after the second fire. The ceanothus so much so that my data collection method failed to collect even a single seedling, which were very scarce throughout the landscape. The chamise were hurt as well, so the seedlings were not doing so hot. Now remember, the ceanothus does not resprout. So on the right-hand side, we're looking at the chamise composition. And the chamise sprouts actually did relatively the same. There's no statistical difference between once and twice burned resprouting. So that's good for that. However, the seedlings, also really dropped. So this is an indication that the seed bank for both of these species may not be as resilient as we hoped. So what does this mean for overall chaparral resiliency? And to get to that, we really have to go back to those recovery mechanisms and really hit home on the fact that those seed banks were not as robust as we thought. So there was essentially a flush of germination after the first fire that was killed by an uncharacteristically short fire return interval. And those species that were germinating did not get the opportunity to become reproductively mature and drop seed bank and add to the seed bank. And so this disproportionately affected that recovery mechanism where the ceanothus cannot resprout and therefore it was almost entirely removed from the landscape. The chamise could resprout and therefore this led to sort of a monoculture, a monotypic stand of chamise is emerging. Now, this is really interesting because chamise is a characteristically powerful wildfire fuel. Not only does it have physical characteristics that make it very prone to burning, it is also full of volatile chemical oils, Another name for it, a nickname for it is greasewood because it's known to burn so readily. This is supplemented by this herbaceous annual herbaceous cover that provides a lot of connectivity between all of these fuels that dries out every year. And so I think this might lead to chaparral becoming more vulnerable to frequent burning. So this is essentially a new feedback loop, right? Where you have this uncharacteristically short fire return interval to start, but then that creates a shift in the plant community where you have shrubs that are more prone to burning connected by a contiguous herbaceous cover that dries up annually. And I think this has the potential to shorten the fire return interval even further because the landscape becomes more prone to burning, which could intensify the effects that we saw by my data. I think that this could be a real concern as it might eventually even overwhelm the chamise recovery mechanisms and lead to a wholesale conversion of chaparral to grassland. So I'm out of time. I really hope that this was interesting to you. If you have any questions, please leave them. I had to rush through a little bit of this, so I really hope that you enjoyed this.